We've provided comprehensive, easy-to-use templates and defaults for schedules and retention settings in Carbonite Safe Server Backup that will serve the vast majority of users' needs. But for those who want to understand more about what they're selecting or how it all works, there are some important concepts to know that may not be intuitive. Let's start with the sample schedule for a file system backup set here. The first thing you may notice is there's more than one entry here. You can stack several entries in one backup schedule. The reason for this will be more apparent once we dig into the details. Let's double-click the first entry. At the top, you can see three options: full, differential, or incremental. Full backups will back up a fresh copy of everything that is selected for backup. Differential backups will only back up what has changed since the last full backup. And incremental backups back up the changes since the last backup of any kind: full, differential, or incremental. Each one of these backups creates a restore point from which you can restore the included data as it was at the time the backup took place. Differential and incremental backups create restore points more quickly and save on storage space used per restore point since they only back up changes. But they both depend on the previous full backup to remain valid as a complete restore point. Incremental backups depend on every previous backup, up to and including the last full backup, to remain a valid complete restore point. Performing a complete restore from a differential or incremental backup requires recovering data from every other backup they depend on as well. For most backup types, this complete restore using the chain of dependency back to the previous full backup is the only way to perform a restore at all. In those cases, if any backup in the chain is inaccessible, none of the subsequent backups can be restored from either. It is possible to restore some data from an individual incremental or differential backup for a file system or Exchange mailbox backup type, but you would have to restore one item at a time and could only restore data included in that particular backup. It should be noted that some backup types have restrictions on the scopes they can use. For instance, system state backup types do not support incremental backups. Other backup types can do either differential or incremental backups, but not both. If you notice that any of these scopes can't be selected for a backup set, that's because they aren't possible in that particular scenario. Each of these scopes has strengths and weaknesses. While it's simplest to restore from full backups, using only full backups takes lots of time to back up and does not efficiently use backup space. Differential backups will be fast at first, but will grow and complicate over time as changes from the full backup compound. And depending on too many incremental backups, while consistently fast to back up, forces Carbonite Safe Server Backup to retain and retrieve data from a very long string of backups during a restore, which reduces performance. As the chain of dependency increases, restores become more complex, and the chance of damage to an incremental backup compromising the chain of dependency increases. With these nuances in mind, how do you maximize efficiency with Carbonite Safe Server Backup? The best way is to use a combination of these backup scopes, and that is why you can have multiple entries in a schedule. Each entry is the scheduled operation for one of these scopes of backups. In this example, we can see this backup set is scheduled to take a full backup once a month, and incremental backups every day. This creates a fresh backup of all the selected data once a month. And any of the data that changes over the next month are backed up in daily incremental backups, creating a daily restore point. After about 30 days, a new full backup runs and a new backup cycle begins. A backup cycle is the period of time between full backups. Backup cycles begin with the full backup and include every incremental and differential backup that occurs until the next full backup. Backup cycles are a useful way to organize backups because every restore point created during a backup cycle depends on the full backup taken at the beginning of the cycle to be a complete restore point. A healthy cycle is very important for a healthy backup, and our default schedules and schedule templates are all designed to follow best, most effective practice. While the backups within a backup cycle are interdependent, backup cycles themselves are not dependent on each other. This makes backup cycles an intuitive and easy way to set your data retention. Retention settings determine how many backup cycles are retained in the local backup location and in the cloud. Once the number of completed backup cycles is greater than the number set here, the oldest backup cycle is deleted. Discarding older backups is an essential part of a sustainable data protection plan. Without a set retention, you will definitely max out your local disk location or reach your allotted cloud storage size at some point. And these issues will need to be resolved before Carbonite Safe Server Backup can continue creating backups. The default values here are the minimum recommended number of cycles to retain. We do allow editing them, but we strongly advise that you do not decrease them. Doing so could leave you vulnerable to intelligent cryptovirus attacks that can go undetected for long periods of time. The only way to completely recover from these types of attacks is to restore your data from a point before the initial infection, so it is vitally important to have a safe number of restore points to choose from. In this example, 2 backup cycles are kept available at all times. Each backup cycle is a month long, and each contains daily restore points. These settings effectively keep about 60 days of recoverable daily restore points available at any given time, which is considered best practice. Reducing this schedule's retention to 1 cycle would reduce the number of available restore points to about 30, which doesn't effectively protect you from more advanced threats. Conversely, increasing the number to 3 will retain an additional backup cycle, effectively keeping about 90 daily restore points looking back 3 months. This is good from a data protection standpoint, but you need to be sure your local and cloud storage can accommodate holding the extra data from another cycle. If either limit is breached, Carbonite Safe Server Backup cannot continue making backups until more space is added or older cycles are deleted manually. Another thing to keep in mind is that Carbonite Safe Server Backup will not delete the oldest backup cycle until the newest one is complete. So you need to have enough local storage space to hold 1 more backup cycle than your retention specifies. You don't have to worry about this for the cloud storage. We provide this buffer space for you. You may also notice that you can change your retention type entirely. If you change your retention type between time retained or number of cycles, you'll see a notice that the change will not take effect until the next full backup. This is important to remember. Carbonite Safe Server Backup does not allow switching retention types in the middle of a backup cycle. Interdependent backups need to have the retention measured by the same criteria. Once a new full backup takes place, the change will be implemented. We've already covered number of cycles since it's the default retention type. The other option is time retained. This discards older backup sets based on age rather than how many cycles you'd like to keep. While you can use this metric, it's generally not as user-friendly. Remember that differential backups depend on the previous full backups, and incremental backups depend on all the previous backups up to and including the last full backup. This often leads to situations where some backups are retained even though they are older than your set retention because another backup that depends on them is not. There are also built-in overrides to ensure that you are never left without at least 1 recoverable full backup that may lead to other unexpected behavior. Because of these factors, we generally recommend using backup cycles instead. If you're thinking about customizing templates or creating a schedule and retention from scratch, please first take note of the following final thoughts. We recommend regular full backups, quarterly at least, but you likely do not need any more often than weekly. The default schedule templates and retention settings have been carefully constructed by our software engineers to fit best practice, make efficient use of your storage space, and minimize conflicts within backup sets. When a backup set schedule has multiple entries, it's possible that they may be scheduled to occur at the same time or overlap. Carbonite Safe Server Backup can run multiple backup sets concurrently without issue, but it cannot run multiple simultaneous backups within a set. In those instances, Carbonite Safe Server Backup will continue working on the active backup and simply skip any others set to run concurrently until their next scheduled time. The default schedule templates minimize these occurrences, but also prioritize the most comprehensive backups when they do happen. In the vast majority of cases, the default templates and retention settings are perfect with just some minor adjustments, like selecting which day of the week for a weekly scheduled backup or which day of the month for a monthly one. Making any major changes to these settings, such as changing between weekly or monthly for a scheduled backup, or changing the type or values under retention, can have profound effects on the total number of restore points and period of time you can recover from, which may not be the best use of your subscription. Okay, that was an in-depth look at the concepts behind scheduling and retention in Carbonite Safe Server Backup. We hope you found it enlightening and that the concepts and recommendations from this video are helpful when exploring customization.